Discover the fundamental laws that govern magnetic forces and interactions. Magnetism is a fundamental force of nature that governs how magnets interact with each other and with magnetic materials. The first fundamental law of magnetism states that magnetic poles always come in pairs. Every magnet, no matter how small, always has both a north pole and a south pole. Unlike electric charges, which can exist alone, magnetic monopoles do not exist in nature. When you cut a magnet in half, you do not get isolated north and south poles. Instead, each piece becomes a complete magnet with its own north and south poles. This means a magnet always equals a north-south pair, no matter how many times you divide it. The second fundamental law describes how similar magnetic poles interact. When you bring two north poles together, they push away from each other with a repulsive force. Similarly, two south poles will also repel each other when brought close together. Here you can see two north poles pushing away from each other. The green arrows show the direction of the repulsive force. The same repulsive force occurs between two south poles, pushing them apart. North to north means repulsion. South to south also means repulsion. The third fundamental law describes how opposite magnetic poles interact. When you bring a north pole near a south pole, they pull toward each other with an attractive force. This attractive force between opposite poles is what allows magnets to stick together and is the basis of magnetic bonding. Here a north pole and south pole are pulling toward each other. The purple arrows show the direction of the attractive force. North to south means attraction, the fundamental principle of magnetic interaction. The strength of magnetic force follows a specific mathematical relationship. Like gravity, the magnetic force between two poles decreases with the square of the distance between them. The force is proportional to 1 over the distance squared. More precisely, the force equals a constant k times the product of the pole strength divided by distance squared. This graph shows how magnetic force decreases rapidly as distance increases, following the inverse square law. Magnetic fields can be visualized using field lines that show the direction and strength of magnetic forces. By convention, magnetic field lines flow out from north poles and flow into south poles. Where field lines are closer together, the magnetic field is stronger. These curved lines show the magnetic field around a bar magnet, flowing from north to south in smooth curves. Magnetism can be induced in certain materials through exposure to magnetic fields. Materials like iron, nickel, and cobalt can become magnetized when exposed to a magnetic field. This happens because tiny magnetic regions, called domains, align themselves with the external magnetic field. On the left, magnetic domains point in random directions. On the right, they all align in the same direction when magnetized, creating a net magnetic field. Let us summarize the fundamental laws of magnetism. First, magnetic poles always come in north-south pairs and cannot be isolated. Second, like poles, repel each other with a pushing force. Third, opposite poles attract each other with a pulling force. Fourth, the magnetic force follows an inverse square law with distance. Fifth, magnetic fields can induce magnetism in certain materials by aligning their internal magnetic domains. Together, these laws describe magnetism as one of the fundamental forces of nature that shapes our world.